Welcome to episode 4 of this series on drawing tablet pressure. We are continuing our discussion of pressure curves. In episode 3, we discussed the basics of pressure curves, and specifically in that video, I was only talking about a single pressure curve. However, the reality of dealing with drawing tablets and creative applications is that you will be dealing with multiple pressure curves, and you will be surprised how many there are. For these kinds of discussions, I like to create diagrams that serve as visual and mental models. We will create what I will call for now a pressure processing pipeline. This diagram goes from left to right. On the left, we start with the hardware pressure response of the pen. And from there, we get a gray arrow. This arrow and every other gray arrow you see represents the movement of logical pressure data through the pipeline. The first place logical pressure data lands is in the driver. All manufacturer drivers implement a global application pressure curve. This will be applied to all applications that are pen aware. Drivers also let you define a pressure curve for use with a specific application, here designated as application X. So if you use application X, that curve will be used. If you're using some other pen aware application, then the global application curve will be used. And I want to stress one point here. The driver has these two curves, but it will only ever use one of them with any given application. The driver will not use the global curve and then apply the application curve. It's an either-or situation. These are mutually exclusive. Then logical pressure data goes to the pen-aware applications. Applications can implement pressure curves in different ways. I'll get into that very soon, but here we see two kinds of pen-aware applications. The box on top, which is listed as Other Apps, these don't have any pressure curve implementation, so they just accept the logical pen pressure data that comes from the driver, and they use that. And this means that if you want to control their pressure behavior, you have to do it in the driver. Then below, we have a specific application X. This application also has two pressure curves. There's a global brush curve, and then there's a curve for a specific brush, in this case designated as brush B. Unlike with the driver, what happens in this case is both pressure curves are used. First, the global brush curve is applied, then the curve for brush B is applied. So in the case of this application X, using this brush, the final pressure response is actually determined by 3 separate pressure curves. All 3 are applied. The pressure curve defined in the driver for application X, the global brush curve defined in application X, and the specific pressure curve used for brush B, also defined in application X. Ultimately, there are 2 pressure responses in this system. And depending on how the driver is configured and how the application does or does not handle pressure, and how you've configured it, you can see that various pressure curves end up contributing to the final pressure response. Pressure response 1 is completely determined by the driver. Pressure response 2 is determined by 3 separate pressure curves. In this video, I'm going to spend a lot of time talking about Krita and Clip Studio Paint. For now, I'm going to introduce you to several brushes from Krita and Clip Studio Paint, and once you understand which brushes those are, then we will add them to the pressure processing pipeline diagram. I'm going to be talking about 4 brushes, 2 from Krita and 2 from Clip Studio Paint. We have 2 airbrushes and we have 2 G-pens. In Krita, we have the Airbrush Soft brush. In Clip Studio Paint, we have a brush called Soft in the airbrush category, so I show it as airbrush/soft. And then we have 2 G-pens. From Krita, we have the Ink 3 G-pen, and from Clip Studio Paint, we have the G-pen. I think everyone probably has a good idea what an airbrush is, but a G-pen is not well known. And actually, it's not a G-pen. That phrase actually refers to a dip pen, which is a special kind of pen, that uses a G-nib. Professionals who create manga use this G-nib. What matters here is that the brushes that have this name G-pen are intended to draw line art. As you can see, these airbrushes and these G-pens are quite different in their intended use and behavior. I have added Clip Studio Paint and Krita to this diagram with those 4 brushes I just mentioned. Krita and Clip Studio Paint both have a global brush curve, and they have curves for their specific brushes. For both applications, the global brush curve is applied, and then the specific brush curve is applied for that brush. The only difference in this diagram between Clip Studio Paint and Krita is that the driver uses the global application curve for Clip Studio Paint, but the driver uses a specific curve for Krita. Why we would or would not use a curve in the driver for an application is a topic we will explore later in this video. But take a look at the far right where you see the section called Curves that Build the Response, and make sure you understand why it says those curves contribute to the responses for those applications and those brushes. For some of you, it may come as a surprise that Krita and Clip Studio Paint have both a global brush pressure curve and a pressure curve for each brush. So I just want to take a minute to show you the UI of Krita and Clip Studio Paint so you can see for yourself. In Krita, there's a dialog called Tablet Settings, and there you'll see the global brush curve. And then when you have a specific brush selected, you can open the brush editor, and then you can see I can apply a pressure curve to some aspect of the brush. In this case, it's being mapped to the size of the brush. And the same pattern is true in Clip Studio Paint. If you open the pen pressure settings dialog from the main menu, you can see the global brush curve. And then if you select a specific brush and open the tool property palette, you can see the pressure curve for that brush. Now, I talk about Krita and Clip Studio Paint a lot because those are the applications I use, but there are many different patterns a pen and wear application may use to handle brush pressure. For example, there may be applications that are pressure sensitive, but they don't implement a brush pressure curve at all. A great example here is Microsoft OneNote. With OneNote, you can draw a line that is pressure sensitive, but there is nowhere in the application where you see or can configure a brush pressure curve. There are applications that have a single global brush curve. There are applications that have a pressure curve only for specific brushes. There are applications like Krita and Clip Studio Paint that have a global brush curve and curves for specific brushes, and they apply both curves as you draw. And there may be applications that implement a global brush curve and a specific brush curve, but they don't apply both curves as you draw. They only use one of the curves. And of course, a pen and wear application may have some other interesting way of dealing with pressure curves. So I want to be clear, I don't claim that all apps behave the way Clip Studio Paint and Krita behave. Things are starting to get a little complicated now, aren't they? There are pressure curves popping up all over the place. We need to develop a clear approach to which curves we're going to use, whether in the driver or in the application, and which kinds of pressure curve shapes belong in those places. We have 4 places we could apply a pressure curve. In the driver, we have the global application curve and application-specific curves. In an application, we have the global brush curve and brush-specific curves. This is my strategy. These pressure curves are in a pipeline. Logical pressure data is flowing from the left to the right. As we think about things on the left side, things are happening earlier, closer to the driver, early in the pipeline. And the effects are going to be more general and apply more broadly. As we go to the right, things happen later in the pipeline, closer to the brush, and they have more specific, more localized effects. My strategy has 2 simple tactics. Number 1, fix big systemic issues or problems as early as possible, and that means in the driver. And then number 2, tweak or customize as late as possible, and that means as close to the specific brush as possible. So we have these 4 places for controlling pressure curves. Now I'll walk through how I apply my strategy for my own work. First, I fix those big systemic problems, and I do that in the driver's global application pressure curve. The 2 typical things I want to take care of here are, number 1, using a pressure curve to get a linear pressure response from the pen. And number 2, I will try to address the drawing on hover problem if it exists and if it is possible to fix here. Now that I've got those big systemic issues out of the way, now I start customizing and tweaking the behavior I want to give me the brushes that work better for me. First, I set the pressure curves to give me a behavior that matches my intuitive expectation of how a brush might behave. For example, I may want my pens and pencils to not vary their width as much as I change pressure. Or maybe I'm using a specific kind of brush where I want a more fluid style with lots of variation in line width. So there, I might make the pressure curve more sensitive to pressure. Or maybe I'm doing some sort of special trick with pressure to achieve a certain kind of artistic effect. These kinds of things are highly specific to what I am drawing and the specific brush and my expectations around it, so I create customizations for those specific brushes. One thing I often do is create copies of a brush. So for example, take the G pen. I leave it in its normal behavior and I create a copy. I'll call it like G Pen 2. And the only difference in that copy is it has a different pressure curve. This makes it really easy for me to quickly switch between different pressure behaviors. If the application does not have a brush-specific pressure curve, then I fall back to the application's global brush curve. And if the application does not have a global brush curve, then I fall back to the driver's application curve. I like my strategy because I think it is logical, it is very clear, it is not really very complex, and it is very prescriptive about where to set the curves. This strategy works for me. I'm not saying that it will work for everybody. You might use a very different strategy, one that works incredibly well for you. If you do have such a strategy that's different from mine, I would love to hear about it. Please leave a comment. Pressure curves have different shapes, and the reality is it is not always possible to express those shapes. For example, you might want a specific shape in the driver, but you just cannot draw the shape. You can't do it there. You have to do it in an application. Here are 8 common categories of shapes. In our series on drawing tablet pressure, we've talked about most of these shapes. But there are 2 I want to highlight because this is probably the first time you've seen them. They're both on the bottom row. The first one is the sigmoid curve, which is just an S shape. And then we have the complex curve. Now the complex curve isn't a specific shape, it's actually a family of shapes. The thing that makes it complex is that the shape can change direction. It can go up and down and up again, that kind of thing. This is in contrast to the simple curve on the upper right corner, which curves up or down but never reverses direction and doesn't do anything fancy. I tested these 8 pressure shapes across 4 different manufacturer drivers and 2 different creative applications, Krita and Clip Studio Paint, and this is what I discovered. The first 4 shapes, null, ignore bottom, ignore top, and simple curve, are supported everywhere, and that's what I expected, and that's great. But the last 4, inverse, constrain output, sigmoid, and complex curve, those are only supported by the application brush pressure curves. And I think this is actually okay because the kinds of things at least I do in the driver are about fixing problems. And those shapes, null, ignore bottom, ignore top, and simple curve, those will address those issues. And those remaining shapes on the right, those are shapes that are really good for special effects and tweaks and customizations that we want with specific brushes. Those don't really solve problems. Let's take a look at the different default brush pressure curves used for brushes that vary the width of their stroke based on pressure. Here are the default pressure curves for 7 brushes from Krita. Just with a quick glance, what do we see? The Ink 3 G Pen and the Eraser Circle brush use a sigmoid pressure curve. I also noticed that the Ink 3 G Pen constrains the output range a little bit at the lower end. The Ink 2 Fineliner and Pencil 2 brushes, they really constrain the output. I think that makes sense for these brushes. They're trying to mimic their real-world counterparts that don't change their width very much as you press down harder. The Ink 8 Sumi E brush has a basic curve that bows down, while the Airbrush Soft brush has a basic curve that bows up. And finally, the Eraser Small brush uses the null pressure curve. And from Clip Studio Paint, here are the default pressure curves for 8 brushes. These curves, to my eyes, have shapes that are not as extreme as some of those curves we saw in Krita. What I'd like to do now is pick a couple of these brushes that are similar between Krita and Clip Studio Paint and compare them. Maybe we can learn something. We'll start with the G Pen. Krita calls it the Ink 3 G Pen, Clip Studio Paint calls it G Pen. Krita uses a sigmoid pressure curve, Clip Studio Paint just uses a null pressure curve. I am not claiming that either curve is correct or incorrect, but I was a little surprised to see that the curves are very different. And now the airbrush. For Krita, it uses a basic curve that bows up. Surprisingly, the airbrush soft brush in Clip Studio Paint by default does not use pressure at all to control the size of the brush. The pencil brushes are also quite different. In Krita, it's called Pencil 2, and we see again it really constrains the output range. So for example, if you set the brush width to 10 pixels, the size of your pencil stroke would go between 5 and 10 pixels and not from 1 to 10 pixels. That makes sense for pencils. Pencils should not wildly change their size based on pressure. Clip Studio Paint has a pencil brush, but it uses a null pressure curve, and so it will exhibit much more variance in stroke width. We've seen lots of pressure curves, but these curves are just mathematical descriptions of how logical pressure values are transformed numerically. What will actually happen if we apply a curve? Let's take this pressure curve. It is the default brush pressure curve for Krita's Airbrush Soft brush. It's a simple curve that bends upwards. And this is a typical shape for the pressure response of an EMR pen. It also bends upwards. This shape means that it is extremely sensitive to the lower end of the physical pressure range. That sensitivity means that it will be difficult to control the size of a stroke at low physical pressure. It's also extremely insensitive at the upper end of the physical pressure range. That insensitivity means we'll be pressing harder and harder, but the stroke size is barely changing. So this typical shape is not ideal. When we apply a curve that bends upwards to a pressure response that bends upwards, the new pressure response is bent upwards even more. And the same problems we saw with the original pressure response are magnified in this new pressure response. So combining this specific pressure curve with this specific pen's response is going to give us, I think, unpleasant results. Let's walk through how the pressure response is transformed in the system. Once we do that, then I'll show you how I would fix this problem. We start with the default pressure response of the pen on the far left. The driver applies the global application pressure curve, which is the null pressure curve in this case. This gives us a new intermediate pressure response, which has the same shape as the one we started with. Then, the pressure curve from the brush is applied. This gives us a final pressure response, which is that very exaggerated curve on the far right. This is the response that has more pressure problems than the one we started with. Where should I fix this problem? I could just change the brush's pressure curve, or I could change the pressure curve used by the driver. Now, fundamentally, the problem is occurring because the pen has that bent up shape. And that's due to the hardware of the pen. And so I consider that a systemic issue. And really, I want to solve these kinds of systemic problems for my entire computer and for all the applications, not just for the specific brush I'm using. So what I would do is I would find a curve that linearizes the pressure response and use that as the driver global application pressure curve. Such a curve would take the original bent up shape and make it more linear. It doesn't even have to be perfect, just more linear will help. And through some experimentation, I find that this is the pressure curve that will perform that linearization. Finding this kind of pressure curve that does the linearization is a real process, and it's a lot to get into right now. Sometime later this year, maybe I'll do a video explaining how to find such a curve in as few steps as possible. Now let's walk through that pipeline again, except this time I'll be using that new curve. We start with the default pressure response, and now the driver applies its curve. And in this case, I'm using that curve that provides the linearization. Now the intermediate pressure response will be linear or very close to it. Then we apply the brush pressure curve. And the final pressure response looks much more like the brush pressure curve. And I think this is giving us the intended behavior from this brush. So a few quick takeaways. We've seen so many places where you can modify pressure with a pressure curve. So you should have a plan where you want to set your pressure curves. I shared my strategy, maybe that will work for you. But in any case, find something that works and just be intentional about those curves. Because there are so many places where curves can exist, when you are modifying pressure, you should check into what's going on in all those places. Especially if you're trying to customize the behavior of a brush or are troubleshooting why something isn't behaving correctly. you might find that these other pressure curves are interfering with your goals. And then we've seen that the default pressure curves for lots of brushes are very interesting. I was very surprised by some of the shapes I saw. So I would suggest that you get familiar with what your brushes are actually doing by default. And finally, experiment, play, have fun, make pressure work for you. At this point, I think we are done with pressure curves as a topic. And now we look forward to episode 5. This is when things will get heated and maybe controversial, because that is when I'm going to talk about pressure levels. And that is where I'm going to tell you how many pressure levels you really need, how important pressure levels actually are, and if they are not as important as we think, then what is important. It's going to be a really fun discussion. Thank you for your time, and I hope you enjoyed this video.